Hi guys, and welcome to this video on a solution of trigonometric equations. Trigonometry, yes! Wow, we love a bit of trigonometry. Now this is a continuation of videos that I've been doing on, yes indeed, trig functions for the Methods 1 and 2 course. And if you're watching this and going, oh, I don't do Methods 1 and 2, doesn't matter. Maths is universal, and I promise you, you will learn here how to solve trig equations, regardless of what course you're doing. A-levels, SATs, Calculus 1, the whole works. So thanks very much for sticking with me. Now, if you haven't already, can I ask a favour? Over there you can see a little red arrow that says something like click to help me. All of these videos are on YouTube and my own maths channel as well, on my own website. And it's great if people subscribe. It sort of lets me realise that actually I'm doing this for a reason and I'm trying to do this to be helpful. So yeah, if you could click that little button, I would be greatly and deeply appreciated. And also if you can tell your friends to sort of head on over and have a look at the videos, that would be great as well. But now, as is normal, what am I going to talk about? Yes, today I'm going to talk about the idea of finding solutions to trig equations, what it means to find a number of solutions, and I'll explain what that means in just a moment, and how to use your calculator. Now the great thing here is in Australia, and I think the United Kingdom, you can use a calculator to find all sorts of different answers. Now the ones over here are really freaking awesome. They're like computers. They can do pretty much everything for you, barring make a cup of tea, surprisingly. A cup of tea, yes please. But the interesting thing is, while in previous lessons we've been looking at the idea of graphs of sine and cosine, and we know the shapes of each of these graphs and how to find the amplitude and period, and if you're saying to me, I'm going to say to you, well, actually, I've got videos. They're there, they're loaded, they're ready for you to watch. It'll sort of explain the whole thing about sine and cosine and periods and amplitudes and whatever else. But you've been doing this since, I don't know, year 9 possibly. And so, for example, you know, you may have seen this example here. You may be given a right angled triangle and you were told that was theta, and you were told that was 1 and that was 2. And, you know, you went, oh, SOHCAHTOA. I still don't know why I do it that way, but SOHCAHTOA. And you go, oh, I know SOHCAHTOA. There's my opposite and there's my hypotenuse. And I know this is sine. And you'd have ended up coming up with this sine theta equals a half. And then what would you do? Well, of course, you'd fire up your calculator and you would go, I can do this. And so you would go, or keyboard in this one, and you would go trig, inverse sine of 0.5, close the brackets. You'd make sure your calculator was in degrees. And as you can see from the arrow that's highlighting now, my calculator is in degrees. And you press enter. And the world went mad. And you'd be, hey, I can do this. And you'd go, well, therefore, theta is equal to 30 degrees. And you'd sort of call it a day. But actually, there are way more solutions than just one that will give me 30 degrees. And if you've watched the previous videos on the unit circle, you'll understand why. But if you haven't, well, it's a good news here that actually I can come up with some solutions for you. Now, the great thing is I can plot this stuff with Desmos.com. If you haven't used Desmos, it's awesome. And no, I'm not being sponsored by them. It's just really helpful. And what I did was say, well, okay, Desmos, can you do me a favor? Can you sketch the graph of y equals sine theta? And what I said was, I want you to limit it between 0 and 2 pi. Now, in this instance, I've done pi, so that I'm in radians, but actually we can convert between degrees. And up comes that red line. And then I said, well, okay, can you now solve y is equal to 0.5? And if you've watched my previous video, you go, oh, I know what that means. Because I can write sine theta is equal to y, I can just switch this around and write that sine theta is equal to 0.5, then what it's basically saying is, can you find all the places on my red line here that actually cross through the line y equals 0.5? And lo and behold, up come these two values here. Now you'll notice that the y values both there are 0.5, which is good, which is what we want. And then we have two solutions. Now there are two solutions because, again, I have said limit my graph between 0 and 2 pi. And those two solutions are pi on 6 and 5 pi on 6. Now the great news is that if I do pi on 6 in terms of degrees, that is 30 degrees, and 5 pi on 6, if you want to convert it, is 150 degrees. So actually there are two values, and we sort of know this because the graph tells me. Being able to do it with algebra, funny enough, is surprisingly easy because we just use the unit circle. And if you remember what the unit circle is, there's my unit circle, all stations to Canberra, yeah? And so, if I knew that sine theta was equal to a half, the great thing is you actually use the calculator to find that first value. You're still going to use your calculator, unless, of course, it's a non-calculator paper. Now, if it's a non-calculator paper, we go back to a different lesson. Well, there's so many things here on exact values. And again, if you remember, we have these triangles, which are 30, 60, and there's 90. We know that's 1, 2, and root 3. And if I'm trying to find 30 degrees, sine is opposite over hypotenuse. And so we can say straight away from that triangle, from my calculator, that the first angle of theta, is 30 degrees. So now I'm going to draw my unit circle, and I'm going to say, right, there is my first and my reference angle of 30 degrees. Where else would sine have a positive value? Well, there's my all, and actually I don't have to go far around to say, oh, there's sine. And I know for this to be true because the unit circle, then that angle there must also be 30 degrees. That will give me the same value of a half here when I do opposite divided by hypotenuse. So, if this is 30 degrees here, this is 180 degrees here, then actually it's 30 degrees before 180 degrees. So my other value of theta is in fact 150 degrees. So I've done all of this without a calculator. So let's look at this example here now. So I'm going to try and find the solutions this time between 0 and 4 pi for the following function. I'm going to worry about the function in a moment, but cosine theta. We don't want sine theta this time. So what I'm going to do is draw a quick sketch. Now, if we remember, cosine theta for one period looks like that. It goes between 0 and that one there is between 2 pi. Now, the question seems to state that we don't want it between 0 and 2 pi. We want it between 0 and 4 pi. So actually what it wants me to do is another revolution or another period. So there is my 4 pi. And so it's now saying find the values of theta where cosine theta is equal to root 3 on 2. Now, if I enter that into my calculator, I get about 0.86. So what I'm going to do is draw a horizontal line along here. Now, you're going to say, why are you drawing a horizontal line? Because remember, this is like saying, find the solutions where the graph cosine theta meets the line y equals root 3 on 2. Now, how many times do you see it cut? 1, 2, 3, 4. So I'm looking for 4 solutions. All right. So now I've got 4 solutions to come. How do I find my first solution? Well, one of 2 ways. 1, use my calculator. 2, use my triangle. So let's use my triangle first, just make sure we can actually do it. So we know that that's 30 degrees there. That's 60 degrees. 1, 2, and root 3. So what angle has an adjacent of root 3 and a hypotenuse of 2? Well, there's my adjacent of root 3. There's my hypotenuse of 2, so it must be 30 degrees. So I now know that theta equals 30 degrees is my right solution, my first solution. But I have to be careful because the question says between 0 and 4 pi, which is basically saying it wants it in radian measure. So I'm not going to get confused. I'm going to stay now in radians. So that 30 degrees is pi on 6. So I've got my first solution. Now I'm going to use my all stations to Canberra. So there we go. There's my all stations to Canberra. And I know that first reference angle there is pi on 6. So where are my other quadrants positive for cos? Remember this angle here, that line there, that number there is positive. So I'm looking for, well, as it turns out, this quadrant here. So I now know that the angle below is pi on 6 as well. Remember, we're always trying to connect that angle to the horizontal axis. So that's pi on 6 there. We're going all the way around now and trying to find out what that angle would be from 0. Well, we also know it's 2 pi. So I can now do 2 pi minus pi on 6. Remember, I can now make that 12 pi on 6 minus pi on 6, which gives me my solution of 11 pi on 6. So there you go, 11 pi on 6, and I'm done. Now, remember, you're actually looking for 4 solutions. Why are we looking for 4 solutions? Look back at my diagram. Okay, so having got those, how do I now find my next 2 solutions? Well, it's great because cosine and sine repeat every 2 pi. So if I've got my first solution as pi on 6, then all I need to do is add on the value of 2 pi to get to my next solution. And if I've got my 11 pi on 6, then I know that if I add on 2 pi, it will give me my next solution. A lot of people go, well, how do I add on 2 pi? Well, again, I will always turn 2 pi into whatever it is over 6. So in this situation, 2 pi is the same as 12 pi over 6. Why? Well, when the bottoms are the same, I can add the top. So again, this is going to be 12 pi on 6. And so, ladies and gentlemen, what am I going to have as my next values? Well, my first value was pi on 6, 11 pi on 6. Now, pi on 6 plus 12 pi on 6 is 13 pi on 6, and the next one would be 23 pi on 6. And there are my 4 solutions. This stuff is overly repetitive. It just goes on and on. It's the same stuff. I mean, if we look at example 3, again, we want it between 0 and 2 pi. So I know that my answers have to be in radians. My question here has minus 0.3. So I'm going to already do my value here of all stations to Canberra. Minus 0.3 means it's going to be down here. Yes, so minus 0.3 means it's going to be down there. But the problem is I don't actually know what my first value of x is. And in this situation, because I don't have my triangle, I'm going to use my calculator. So, firing up my calculator. Now, in this situation, if I do inverse sine of negative 0.3 and close my bracket, I'm going to get minus 17.45, blah, 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 blah. But interestingly, that's in degrees. This question is in radians. This value here is in radians. So I actually need to make sure my calculator is in radians. So changing it down there for my Casio ClassPad, I'm going to go back. I'm going to hit enter again. And in this situation, out comes minus 0.3. So I know my first value of x is equal to minus 0.3046, and so as it goes on. Now that's my first value. But the problem is it wants it between 0 and 2 pi, so that value is actually no use to me. So I'm now looking for other values where sine is negative. So we now know that this size here is 0.3046. So this must be 0.3046. You're going to say, well, what does that have to do with the price of fish? And I'm going to say literally nothing. But we now need to say, well, that was 0. This was pi on 2. This was pi. This is 3 pi on 2. And this is 2 pi. So now I'm going to go around my circle the right way and work out my values. So if I take the value of pi and add on 0.346, that's actually going to give me my first solution. So I'm going to take pi and I'm going to add on this positive value. Now all I'm doing, if you see on my calculator, is highlighting it and dragging it down. Not the minus sign because I'm not interested in that. And that gives me my first value of 3.45. 3.45. And I'm going to leave that to 2 decimal places. How do I get to my next value? Well, I'm going to continue around the circle. And this time I'm going to take away 0.346 from 2 pi, because that's going to give me my other value. So my other value, loading up my calculator again, gives me now 2 pi. So 2 pi minus that positive value again. Oop, don't want that. Please just give me the number. Thank you very much. And I put equal to and 5.99. Do I need to go any further? Well, absolutely not, because I now have my values that go between 0 and 2 pi. Do I need to do another? Do I add on 2 pi? No, I'm done. Now, the point of this is, with this question here, although the calculator gave me the first solution, it was negative and it didn't fit into my range. So I had to interpret that in the right way by using my all stations to Canberra. Now again, we can use a calculator to do all of this for us, believe it or not. So I'm going to load up my calculator and show you how. By using this wonderful thing in Maths 3 iCalculator called, surprisingly, Solve. And I can say, yo calculator, I want you to solve the following equation. Now I don't do the inverse because I'm going to put my equation in. The cosine of x, close brackets, is equal to minus 0.3. I'm going to put a comma to say, I want you to solve for the value of x, and I'm going to close my bracket. Now if I press enter now, my calculator is going to give me some really funky answers. And you see that 6.283187 dot constant 1? Well, the calculator is basically saying, well, that constant 1 means that I've got loads of values here. In fact, I'm going to give you what we call the general form. I'm going to give you a way for you to work out the infinite number of answers that you've asked me for. And you've actually asked the calculator for an infinite number of answers. Well, you don't want an infinite number. You want to limit that between 0 and 2 pi. How do we know that? Well, the question here says limit it between 0 and 2 pi. So, how do I do that on my calculator? Well, it's actually easy. Going to Math 3, I can put this vertical line, and that vertical line says limit my domain. All right? It can also say put a value in, but that's beyond this. And what I'm going to say is I want to limit it between 0, less than or equal to x, less than or equal to 2, and pi. So again, I'm putting that in terms of radians. I hit enter, and lo and behold, after a couple of seconds, up comes 1.875 and 4.4. And those are my two values. There are no other values. I mean, if I try and go across to my calculator, no, it's giving me those two values, which is what I was expecting. And I would write that down as it was. So 1.87, so x was equal to 1.88, and the other value would be x is equal to 4.41, both to two decimal places. Now, your calculator is great, and if you're on a non-calculator paper, sorry, can't do that. If you're on a calculator paper, my advice is use it to check. Now, the last part of this particular lesson looks at two questions here that take it a little bit further. And they're great. They're formulaic. They work in exactly the same way. But what you'll notice now is we have a 2 theta here. That fudges the lines just a little bit, but it's a trick. Same process works, but it's just a trick. All right, so ready? Here we go. First thing I'm going to do is I'm going to say, well, look, I want my values of theta originally between minus pi and pi. So first stage there, minus pi and pi. Well, what I'm going to say is let x equals 2 theta. Right? I'm going to let x equals 2 theta. So I'm now going to solve this for the sine of x is equal to minus the root 3 on 2. And that's a bit of a fudge. Now, because I'm making x 2 theta, what I now have to do is I have to double each of those values for my domain. So what I'm now going to do is say, well, hold on a moment. I'm now going to solve between minus 2 pi and 2 pi. It's just a fudge. What we're sort of saying is, we're going to rethink the question. Rather than going between minus pi and pi, we're going to go between minus 2 pi and 2 pi. Whatever this value was here, 2 theta, I'm going to double if it was 3 theta, I would triple it. If it was a half a theta, I would halve it. And now I solve the question in exactly the same way. So I've got sine of x is equal to minus root 3 on 2. So I want to get my first value. How am I going to do that? Well, absolutely, I'm going to use my calculator. So loading up my calculator, I'm going to say, okay, calculator, do me a favor. Can you find the inverse sine, please, of minus root 3 divided by 2. Close my brackets. You'll notice I'm in radians. And I'm going to hit enter, and out comes my value of minus 1.047. So minus 1.047 ... That's my first value. Does that fit into my minus 2 pi and 2 pi? Well, absolutely. Aishikoko, of course it does. How do I get to my next value? Right, well, I'm going to draw my unit circle. Here's my unit circle. I've got x is minus 1.057, so all stations to Canberra. Yeah, so minus root 3 on 2 is down here. So that value there is 1.047. Where else is sine negative? Happens to be down here, so 1.047 there. And again, like we did with the previous example, this is 0, this is pi, this is 2 pi. So I'm now going to add 2 more values to this. I can do that. How can I do it? Well, because this allows me to do it. Right, so pi plus 1.047. Fire up my calculator. Hey, Mr. Calculator, can you do pi plus? Now, again, I'm not going to round the value. I'm going to use my calculator and take as much of that value as I possibly can. Add the 1 on the end. And then it gives me 4.188. So 4.188. And I want to do 2 pi minus that value as well. So I'm going to do a comma here and a comma here. And I'm going to say, hello, Mr. Calculator, can you do 2 pi minus the value we had? Thank you very much. Again, copying it down. Oh, my calculator. My copy and paste is not working. That one does not want to copy. Gives me 5.24. So 5.2, let's not do that, 5.23598, blah, 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 blah. Now, do I have all my values? Sadly not, because I'm expecting 4 values. And I'm not going to get 4 values here. So I'm going to delete that x because I've got 1 value, 2 values. Those are between 0 and 2 pi, but I've only got 1 value between minus 2 pi and 0. Well, one of them was minus 1.47. How am I going to do the other one? Well, I can take away 2 pi. If I take away 2 pi from this value, I promise you I will get that value there. And just bring up my calculator and I'll show you. So if I take this value here and I take away 2 pi, because it repeats every 2 pi, I get minus 1.047. So now what I'm going to do is I'm going to take my 4.1888, I'm going to take away 2 pi, because we know there'll be another solution 2 pi that way. Hit enter, and I get minus 2.094. So I get x is equal to minus 2.094. And you might argue, well, that's at the end of the question. I go, no, sorry, sadly not. Because remember, we were just solving it for x. We made this value of x. We sort of introduced it, but it doesn't. It wants solutions of theta. But hold on a moment. We know that x is equal to 2 theta. So I now know 2 theta is minus 0.94 dot 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 minus 1.047 dot 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 4.188 dot 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 and 5.23598 dot 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 dot. So how am I going to get my value of theta? Well, I should go. I'm literally going to divide all of those by 2. Two 0.618. All right, and there we go, ladies and gentlemen. There are my 4 values. Now, I made that look difficult. I promise you it isn't. Yeah, more calculated. It just doesn't like me. One more example. Solve the equation root 2 sine 3 theta equals minus 1. It is a massive trick. The idea is you're trying to get sine on its own to start with, and that root 2 looks complicated, but it really isn't. All I'm going to do is shift it to the other side. So I have sine 3 theta becomes equal to minus 1 over root 2. All right, now it's telling me that it wants the x values to be between 0 and 2 pi. And what I'm going to say is, okay, that should be theta, by the way. So wants the theta to be between 0 and 2 pi. So I'm going to say let x equals 3 theta. And so now I want to solve this between 0 and 6 pi. I'm just going to times all of these values by 3. So I now have the sine of x is equal to minus 1 on root 2. Oh, I can do this. So minus 1 on root 2. So x becomes equal to, well, I can actually use my triangle. Let's do that to try and make things slightly easier. So there's 1, 2, and root 3. That's 30 degrees. That's 60 degrees. I want sine, which is the opposite over the hypotenuse. So I want the opposite as 1. Don't worry about the minus sign for the moment. Opposite is 1, and I want the hypotenuse as root 2. Oh, it's not that triangle. So it must be this one. It must be this 45 one. So here's my 45. Here's my 45. There's 1, 1, and root 2. So hypotenuse, yep. And so actually, it's 45 degrees. Now, we don't want to write 45 degrees. We have to have that as pi on 4, because we're dealing with radians. So actually, nicely, my first value is pi on 4. Oh, but it's minus, so it has to be minus pi on 4. Right, we've done that. So let's move it up a little bit, and let's draw my unit circle. Here's my unit circle. Thank you very much. All stations to Canberra. Now, we already know it's minus, so it's got to be here. It's the first one, because when you go minus, you go around the unit circle the other way. What are we looking for? Sine to be negative. So again, it's got to be here. So that again is pi on 4. And so I can find my next solutions. I can find 2 solutions by saying, here is 0, here is pi, and there's 2 pi again. So I've got pi plus pi on 4 is my next one. So pi plus pi on 4. And then my one after that would be 2 pi minus pi on 4. Let's try and make that slightly easier. So we've got minus pi on 4. I can change that to 4 pi on 4. So that's going to be 5 pi on 4. And then this next one's going to be 8 minus that 7 pi on 4. So have I got all the values I need? Well, sadly not, no, because I'm having to go and get all of my values between 0 and 6 pi. Well, interestingly then, that means this cannot be a solution. Why can it not be a solution? Because 0 and 6 pi can't have a negative value. That was useful as my first value. It helped me set up my unit circle. But other than that, that's no use to me. So I now need to find how many more solutions. Well, 4 more solutions, because there are 2 in 2 pi, 4 in 4 pi, 6 in 6 pi. I've got 2 solutions. And how do I do that? by adding on 2 pi to each of those values. Now, add on 2 pi, that becomes 8 pi on 4. So all I now need to do is add 8 pi to each of those top numbers. So 5 plus 8 is 13 pi on 4. And the next one, add 8 to that, will give me 15 pi on 4. And then add 8 to this, gives me 21 pi on 4. And the next one gives me 15 and 23 pi on 4. And I'm finished. Yes, that's the end of my question. No, because remember, we made x equal to 3 theta. But we need to go back to my value of theta. So using that now, I know that 3 theta is equal to 13 pi on 4. Sorry, let's start actually with the first values. 5 pi on 4, 7 pi on 4, 13 pi on 4. It actually takes longer to write this bit out than it actually does to solve the problem. 21 pi on 4 and 23 pi on 4. So now I'm going to divide all of those by 3, which gives me that theta is, when I divide each of those by 3, it's the same as timesing by a third, which gives me 5 pi on 12, 7 pi on 12, 13 pi on 12, 15 pi on 12, 21 pi on 12, and 23 pi on 12. And interestingly, none of those cancel down other than the 15 pi on 12, which you probably could. Ladies and gentlemen, believe it or not, solving trig functions comes up in literally every single exam I have ever seen in my entire life. It doesn't matter if it's A-levels, if it's SATs, if it's the VCE, unit tests, end of year tests. One of these questions will be on, categorically. And if I'm going to put money on which question will actually come up, it will undoubtedly be one of these here. It's the easiest way to test your algebra, your trig, your unit circle, and pretty much everything to do with trigonometry. So my advice to you is practice these type of questions over and over and over again. If you don't understand them, go back and watch my videos. Ladies and gentlemen, a long lesson. I'm really sorry about that, but hopefully useful. Now, go and practice. Particularly if you're in my group, definitely go and practice. As usual, it's great to see you. If you haven't already done so, do me that favor and spread the love. Don't love me, because that's a little bit weird, but spread the love and try and tell people out there on Facebook or Instagram or Twitter that I'm here, and direct them this way, and subscribe maybe. That would be really, really helpful. And if not, there's a video loading over there. Thanks very much for your time in watching this. I look forward to seeing you next time. All right, this is MaffsGuru, out. Take care.